how can this be? Light has existed in the universe from its earliest moments and will continue to exist long after humanity and the stars are shred to dust. But just how does it work, and how can it seemingly last forever? And perhaps most importantly, what even is it? The newly born universe buzzed and frothed with boundless energy. Even after the raging furnace of the first few minutes had died away, temperatures universe-wide were more than 100 million degrees. For thousands of years, this primal heat burned a cosmos of plasma, a superhot mix of particles and radiation. Until, one day, it changed forever. That day arrived when the universe was almost 400,000 years old and had cooled to about 3,000 Kelvin. In this now comparatively tepid soup, lone electrons met lone protons and finally could stick together, forming the first atoms. But this was not all, for as each electron and proton bound together, a small amount of energy was released. A packet of energy that raced away at the cosmic speed limit, the speed of light. A particle of energy born in the formation of a hydrogen atom. A particle we call a photon. A particle of light itself. This photon was far from the first, but as the universe began transitioning from plasma into neutral gas, light could then, for the first time, stream freely through its reaches. And so, our photon's long journey began. It headed out first into the universe's dark ages, a time before the first stars burned, a time before the first galaxies formed. In the eerie darkness, gravity pulled on mass to mold the first seeds of cosmic structure. But the photon sped on and noticed nothing. Eventually, the first stars burst into life around it. Massive and bloated, these ancient suns burned themselves out in a cosmic blink of an eye as the first supergiant black holes grew rapidly between them as they eagerly devoured mass. But the photon sped on and noticed nothing. The first galaxies began to assemble. The sky lit up with the fires of uncountable young stars across the cosmos as they began to fuse the initial hydrogen and helium atoms into heavier elements. But the photon sped on and noticed nothing. Millions steadily turned into billions of years, and as galaxies grew and matured, eventually the intense light of young stars began to settle. The photon's journey could have potentially lasted forever into eternity, but after almost 14 billion light-years of travel, a large spiral galaxy steadily came into view. Its destiny was set. Near a small blue dot orbiting a small white star, after crossing the last few thousand light-years, the photon collided with a piece of metal, part of a telescope built by humans and orbiting near the planet Earth. The photon's energy was completely absorbed, energizing electrons and registering on detectors. But as the photon vanished from existence, its billions-year-long journey complete, it still simply did not notice. Because, to the photon itself, the journey never took place. 13.8 billion years of cosmic time disappeared in an instant. Light is fast. It only takes 0.13 seconds for it to circulate the entire globe, slamming into speeding particles before it had a chance to travel anywhere, one piece of light dying as another was born. However, our parcel of light was born into a very different, very transparent universe. With the cosmic maelstrom of the Big Bang finally abated, our photon could begin its immense journey unhindered. As it traveled, many generations of stars led to our sun, and billions of years after, humans began to walk on the surface of our small, rocky planet. And so eventually, as our photon was a couple of thousand light-years distant from Earth, those humans began to wander. All men by nature desire to know. An indication of this is the delight we take in our senses, and above all others, the sense of sight. This, most of all the senses, makes us know, and brings to light many differences between things. The ancient Greeks wondered if light emanated from the eyes, touching and feeling the world around us. But clearly there are times when it is dark, when we can't see anything. So they concluded light must be something external, something captured by our eyes. Islamic scientists went on to unravel the properties of light, finding rules of reflection and the magnification properties of glass lenses. Light was clearly a natural part of the universe around us. Think of a child on a swing. As they swing, their position oscillates from one position to the next and then back again, just like a pendulum that drives the regular ticking and tocking of a grandfather clock. When oscillations act in unison but slightly out of step, waves are formed. A stone thrown in a flat pond pulls the water down with it, but the water bounces back. This splash of water pulls on its neighbors, inducing them to oscillate, which in turn pulls on their own neighbors. These oscillations fan out across the pond as a steadily rippling pattern of waves. Waves are everywhere, from sound waves coursing in the air to ocean water waves driven by the wind and moon. Seismic shifts can generate violent and destructive earthquakes in our planetary crust, whilst similar waves ripple in the atmosphere of the sun and other stars. And so, light seemed also to be a wave. Our cosmic parcel of light was born when a proton captured an electron. It sped out into the universe, powerful and energetic. But as it traveled and the universe expanded, it started to lose some of that energy. The light, originally blue to our eyes, steadily morphed through the colors of the rainbow and into the red. Soon it was joined by other energetic light shining from countless billions of newly formed stars. There were different types of light as well, light of exceptionally high energy and light with barely any energy at all. The universe was awash. Of course, our light did not know that these would be invisible to human eyes.
Thanks for watching. Show your support by subscribing, ringing the bell and enabling notifications.